Okay, let's continue. Just now we have seen that for Sklearn it doesn't want to deal with the categorical features. So if we have a data frame with all categorical features and we want to send it for the training, and Sklearn will say no, we don't want to take that. So how can we deal with this? And in the last week we have already learned there is a thing called one hot encoder, right? So that's one way to deal with that. And in this example, I'm going to show you something else that is called label encoder. So it is in the pre-processing, and I want to create an instance of the label encoder. And after that, I want to do the label encoder fit and transform only one column, the graph feature dot outlook, right? So I take only one column and then I want to do a fit and transform. And guess what? I got an array. So it will take the column of the outlook, and it is a categorical feature, and then it will transform all the possible features into three possible values, and they are 0, 1, 2, and 0, 1, and 2. Okay, and why this one is different? So how this one is different to the one-hot encoder? So for the one-hot encoder, if there are three distinct values, and what are we going to do? We are going to create three columns: feature 1, possible value 1, possible feature value 2, and possible value 3. And for each of the feature, and we are going to have true or false. And later, for the possible value 3, we can throw that away because we can always throw one away, and then we can still keep all the possible values. But in this case, we are transferring one categorical column to one numerical column, and they are 0, 1, 2. Okay, so if we want to do that for everything, and eventually we want to keep the outlook, temperature, and humidity windy, those four possible columns. However, for those all the possible values in those categorical features, they will be changed to 0, 1, 2, 3, depending on how many distinct values do we have. Okay, so how do we do that? We just do the fit and transform, and we just apply that to the entire categorical feature data frame, and then we have that. So now we have transformed a data frame of four categorical features into all numerical features. Okay, so it seems that we are good to go, right? And we can just train the model. So now, since we have already transformed that into a numerical data frame, now Sklearn can deal with that. So far so good. So the next sample. Next, how about we want to do a prediction? And the sample is overcast, hot, normal, and false. Okay, so in this case, this sample has to be transformed into four numerical features again. But I have a question. So just now, in this box, we created a label encoder, and then we transformed all the categorical features. However, for the new sample, we want this to be transformed in the same way we transform the training data set, right? So for example, if overcast, in the outlook, it will map to 2, for example, and then, in the training set and in the testing set, it should the overcast as the same thing, and same thing for the hot, and same for the normal. So however those values are transformed in the training set, we want the new sample to predict to transform in the same way. So how do we guarantee that? Okay, and in this case, we want to keep a record of how those distinct features are transformed. So this will be a dictionary. So eventually, when we transform each of the column, we want to keep a record of the label encoder on how this column is transformed. So for example, what we want to do is something like this. So we create in the humidity. This is a categorical feature, and then we want to create and keep a label encoder telling me how all the possible values are transformed in the humidity column. And same thing for the outlook. I want to have another dictionary which keeps a record on how the possible values can be transformed in the outlook column. So we want to create a dictionary of label encoders like this. So we first create a dictionary, and after that, as we transform each of the column in the training dataset, we also want to keep that in as part of our dictionary. So after we have transformed the training set, and we will have this dictionary, and this is a dictionary of label encoders. So later, if we want to transform a new dataset, for example this one, so I'm making the new sample a data frame and with only one line, and then we just keep that as a data frame, and after that I want this data frame to be transformed as well. And how do we do that? So just now we say we have B as a dictionary of encoders, right? So now what we only need to do is in the outlook, I want to pick up the encoder, this one, and then I want to apply this encoder to transform this overcast into this 0. Okay, and the same thing for temperature. So for the temperature, I know I have already got a label encoder here, and I want to apply the same label encoder to transform this hot into a 1. So, well, this will guarantee that everything will be transformed in the consistent way, and this is very important. So eventually, well, we want to do a fit, and then we want to predict the only sample we send, and then it will say it is a yes. So given the new sample and using our prediction, and it will be a yes. So in this case, this person will play golf. Okay. So the next part, well, you want to start from the same graph dataset, but let's just read everything again. And now we want to predict a new entry. So try to make this new sample an entry in the data frame, and then try to transform that again, and then do a prediction on this sample. And and I'm gonna stop my video here, and so you can do your own coding and try to get the results using the naive Bayes. Okay, I will see you in the next video.